I want to jump right into show and tell and show you a piece that I just added to my personal collection. This is a meteorite that I've been wanting a substantial sample of for about 2.5 years. Hello, everyone, and welcome. It is Wednesday, the 15th of June, 2022, and we are here together for the 109th in a row Knowledge Bowl at Hangout, sponsored by Toperspin Meteorites. Today, we're going to be having part 2 of our Not So Ordinary Chondrite show. Today, we're going to be focusing on Rumurutis, Enstatites, ungrouped chondrites, F-type, G-type, and K-type. Those are some really out there ones, the F, G, and K. So I don't have any. We're going to rely on our crew for show and tell. We also rely on our crew. We have some video that we're going to enjoy today from Roberto Vargas and Greg Shanos and probably someone else. So I want to jump right into show and tell and show you a piece that I just added to my personal collection. This is a meteorite that I've been wanting a substantial sample of for about 2.5 years, and I finally got it. So let me show that to you. All right. So this is the piece I've just added to my personal collection.
Very nice.
Very nice. Wow.
It's nice so nice. Polish. You have to hold it at a certain angle. There it is.
Oh, geez. That's glass.
Etched as well.
I'm sorry?
Is that etched as well?
No, this one is not etched, and I was thinking actually about sending it to Mike to get it etched, but I'm not sure. Mm-hmm. Does anyone have a guess as to what pallacite we're looking at?
Okay. I'd say by the fingerprint that it's probably a toperite.
Look like a spring water.
So, it's not Imalak. I actually heard the correct word, correct name.
I agree with Oz. That's Fukang.
Yep. This is my very own piece of Fukang from China.
I'm so glad we get to see that like really close up like that with such good photography, because I've never really fully appreciated that meteorite.
Yeah.
Well, welcome to Fukang ownership.
Yes. Thank you. Beautiful, stunning piece. And I have to thank our crew friend, Mr. Roberto Vargas, for my just over 11-gram personal piece of Fukang.
Genuine Fukang. Yes.
Yeah. So I'm going to put this away real quick.
Fukang is polished quite a bit. I've seen a lot of mere polish and fewer etches on Fukang. Is that something about its structure that lends itself to polishing better?
I don't know. If anyone knows, does anyone have any feedback on that?
I don't know. Well, my slice is also pretty highly polished, but it's not etched.
Yeah. My only thought about that is maybe a large, back in the day when a large slab was made or finished, it was polished and then cut up. And that's all we can afford.
That sounds logical, actually.
Yeah. Well, that actually talks right into our next piece of show and tell. A lot of times we show very expensive rare meteorites, and there's a price tag attached to that. So I wanted to make sure that we share the lower end dollar range of collecting meteorites with people, because you don't need to spend $50, $80, $200 a gram for beautiful meteorites. So I actually have a few unclassified NWAs, Northwest African chondrites. These are stony meteorites. They've been cut in half. Some are slices. One I cut myself, and they're really not that expensive. You're talking about between, if you go down to the Tucson show, you can get them for 50 to 70 cents a gram. But $2 a gram covers you on most NWA unclassifieds, and the results are amazing. So take a look at this, guys. All right. This is our first example. Tiny little patch of fusion crust. But I actually cut this open with a friend of mine, and we just fell in love with the interior of it.
Nice.
Oh my goodness.
Yeah. Now these have been spray coated. They have a little bit of a sealant on there. I'm not that good of a polisher. But this is a great example of, you cut into enough meteorites and you find a bunch of beauty inside. And these I probably got for less than $1 a gram. Here's another one that I thought was really, really interesting because of the natural hole that was caused by the cut.
Oh, yeah.
More of a weathered meteorite, doesn't have any remnant fusion crust at all on it.
Yeah, beautiful.
Nice surface.
Metal and trollite in that big nodule.
Yeah.
And I love the fact that it's right next to the natural hole, so you can't miss it.
Yeah.
Yeah. So,
What's going on in the lower left there, Topher?
I'll get there in 1 second. Pat,
Okay.
Which one is the trollite? The center?
Yeah, the
Or the-
trollite will be the part in the center. It has a darker, less metallic look to it.
Then the camosite.
Yes, well, so the metal is going to be a combination of taenite and camosite. In the little blebs of metal in ordinary chondrites, they're oftentimes mixed up. They're not really crystallized out.
Gotcha. All right. And thank you. Cliff, is that what you were asking about?
Yes.
Yeah. Just some kind of inclusion or class. I'm not exactly sure how that.
Cool.
It looks like maybe a cracked chondrule.
Oh,
I'm not.
Kind of an irregular shape and has some really interesting scalloped sort of shapes around it.
But see, that is the very definition of exactly why I'm showing these off.
Mhm.
They have interesting things to them inside. Again, here's one that has really no fusion crust, no remnant crust, but you cut into it and it's a beautiful, gorgeous orange color.
Oh,
Yeah, and being the first one to see the inside of the rock in 4.5 billion years never gets old.
No,
That's cute.
always exciting.
Yeah. So
And
now-
those are less weathered than some because you do have quite a lot of free metal in them still.
yeah, and it's not, you can see on the outside, it's not really, there's no ring of like orange around the iron that's sticking out.
Hmm.
So it's, yeah, you're right. It's not super weathered.
Yeah, a lot of the coloring, that orangey mustard yellow sort of color, a lot of that is about the trollite, which is FES, changing to limonite. And that it tends to migrate through the matrix and even stain some of the chondrules. So that sort of characteristic color you see there is oftentimes from trollite becoming limonite.
What explains this color then? Leopard print.
yeah.
With a nice piece of metal right there. Right there.
Yep.
I just like the variety of color in this one. And then here is, you guys know I'm a big fan of H's. So that has got to be an H. Well, again, with the magnet test.
I was going to say,
Lot
how's your
of
magnet
metal.
do on that?
Is that a big chondrule on the top on the other side?
I know.
Right in the middle. Right. Not all the way half. Yeah, there.
Yeah.
Look at the chondrules in that with all the metal. That's kind of cool.
Yeah.
Mm-hmm.
Now this next one, yeah. So I love H's. So I love all that metal. This next one is not an H, but I still love it. I cut this one myself at the Meteorite Mansion, and my buddy Travis Howard has the other half of it.
Oh, yeah.
If you notice right over there at 8 o'clock, you got a little something starting.
Yeah.
Makes you wonder what the other side looks like, huh?
Sure does.
Wow.
Holy.
Oh.
Holy cow.
Wow.
Bullseye.
Yeah.
Bingo.
Centimeter across.
Oh man.
Every once in a while, you get lucky, huh, guys?
Yeah.
That's amazing.
Yeah,
Is that
and
about a centimeter across?
I knew at the time, but I don't know now. I'm sorry.
Yeah. looks like about that big. Yeah. And the
That could
interesting
be.
thing too is that so we call those megachondrials.
Right.
And they can show up in all different classifications of ordinary chondrites. There
Right.
is the odd megachondrial thrown in too.
Yeah. Nice.
On the other side of that slice, Topher, there was some kind of a void. Was that did a chondrule fall out, or is that weathering, or on the upper right there?
Upper right. Oh, up
Okay,
there.
it looks like exterior. Okay, that's an
Yeah.
exterior.
Exactly. Yeah. Yeah.
Gotcha.
So that's just another example of why you don't need to pay huge money for classified meteorites. I'm all in favor of, buying meteorites, but sometimes if you're on a budget or you're just getting into meteorites, it's not a bad idea to get some unclassified. You can already get them sliced up and prepared, or you could invest in a saw and start a new hobby of cutting meteorites and see the inside for the first time ever.
I'll add to that. I super enjoy cutting NWAs, unclassifieds, because for the price they're at and the enjoyment of opening them up, slicing them, being the first person to see inside that particular meteorite, there's nothing like it. There's just nothing like it.
Yeah. We enjoyed that at the Meteorite Mansion. We cut a lot of Zara, so they were all similar, but we're always looking for the unique feature. This one have a metal vein in it. Oh, look at the voids in this one. There are other ways you can go with meteorite collecting rather than unclassified cheapies. You can go balls to the wall and do a collection like Geoff Notkin. Geoff Notkin is one of the meteorite men of the TV show. He's having his collection sold at auction. And this is the guide, the catalog book for it. There may be some still available. If you reach out, you can get one. It is a fantastic capper on a great career in meteorites. This collection and just the information, the photographs, this is a collector's item right here. So I'm really glad that I got this. Geoff, thanks for sending it to me. And we tried to get Geoff on the show today, but didn't quite work out. Okay. Well, we're going to jump into the show and tell feature now that's focused on today's subject, which is not your ordinary chondrites, Enstatites and Rumurutis. So jumping into Enstatites is Pat Brown. What do you have for us, buddy?
Yeah, so I have some Haggounia 001. And so Enstatite chondrites are fairly rare. They represent a very small percentage of the total mass on chondrites, but Haggounia 001 is quite a bargain. The MetBull claims that it has a 3-ton total known weight, but I think it's probably closer to 10 tons because every time you go to Tucson, you see a box of Haggounia 001 pieces, and they're ugly little spuds for the most part. This is a hole of one that I got quite some time ago, and I had a go at cutting this one, and it sort of basically crumbled into a bunch of pieces, and but it shows really good look at weathering. This vein here is all full of terrestrial material from weathering, and I was happy with this one because it had one bit up here that shows some of the blue color of the unweathered part of this meteorite. So this thing has a big stern field, a lot of mass, and most of the stuff fell into what is now a dry lake bed that's very alkaline. And so it weathered the crap out of the stuff. And my background here is not my kitchen countertop. That is actually a 750 gram slice, very thick slice of Haggounia 001 that shows the rare unaltered material with abundant chondrules.
And Pat, let me just jump in and you can take over. one of the reasons why Haggounia 001, you were having trouble with it falling apart, you were showing us a brown all the way to the highly sought after unaltered blue, is because this is a very old meteorite.
Yes, thank you, Tupper. That's a very good point. The terrestrial age on this meteorite is very old, and so it's even though it's been in the desert, it's been subject to weather and water and rain and all the chemicals in the alkali dry lake bed. But again, it's a great example of a meteorite that is a fairly exotic type that is quite available. And this year in Tucson, there was a box of these things for 10 cents a gram. So
yeah, not that quality.
Not this quality. Although this one was, this was probably a once in a lifetime thing.
Yes.
750 gram slab was $100. So
yeah, you that was the deal of the show for you. That was, I was with you when you got it, where I was there right after you got it and showed it to me, and I was like, whoa, it's blue.
Nice score.
Yeah. Congratulations. Thanks for sharing, Pat. I appreciate it. Did you have another one or anything else?
Just got a box of meteorites from Northwest Africa direct. And this was one of the collection of meteorites in a bag. It was a kilo of them, and they were all different. This one's fairly small, but the red chondrule in the lower left there is really interesting. This one is almost certainly a type 3 and shows a lot of broken chondrules, and it wonderful under the microscope.
Wow,
thank you.
It is. Yeah, that looks beautiful, man. Yeah, seems like you have a box arriving from Africa every week now.
Yeah.
All right, I have no idea what Marissa has to show. I think it's an Enstatite. Marissa, what do you have for us?
Well, what I have is an Enstatite, and it's an EL melt. It is NWA 7401, and it's 6.3 grams.
This meteorite shares some textural similarities with Haggounia 001, although its plagioclase composition is slightly higher in AN dot. Not sure what it's higher in. It's higher at something.
This is 7401, an EL melt. That was, I think, one of the classifications they put on Haggounia at one time. That thing's been reclassified and restudied so many times. I don't think I have any of this one, Marissa. I think you beat me on this one.
Yeah, I picked it up at the Tucson Gem Show. I went over to Susan Morrison's shop, and she was just throwing out a whole bunch of meteorites, and her shop was a little messy as it was still relatively new and she's still getting things out and organized. So I didn't have this classification and she had it, so I swiped it up.
Wisely so.
Yeah.
Huh? Nice piece.
Yeah, there's lots to be had in Tucson. Awesome.
Very nice.
Marissa, did you also have the EH3?
Yes, I do.
I could use those fingernails when I'm doing my Mars micros.
Ooh, that one. Those are wild fingernails. Pretty.
Yeah.
So this one is Sahara 97159. It's an EH3.
Cool.
NWA.
It's 10.9 grams. It's a very thick slice.
Beautiful.
It's got it's got a beautiful shape to it. I love the natural shape to it.
Yeah, it's amazing. I am pretty pleased that I was able to swipe this one up, by the way. Yep.
Ooh.
There you go.
Oh, wow.
Perfect.
Wow.
Jeez.
Back up a little
Very
bit.
nice.
That is so unique.
Take it back again.
Yeah, what is the metal content of the Enstatite family as a percentage? Do you know?
I'm
Oh, a
hoping
little too close to the camera.
I'm hoping Mike will have that answer in our 101 coming up next.
Oh, okay.
According to the Cambridge Encyclopedia, it is 17 to 23%. It's entirely camosite, which is the nickel poor alloy of iron and nickel.
Wow, that is a beautiful meteorite. It has a weird surface shine to it. Wow.
Yeah.
Thank you so much, Marissa. We appreciate you and your help getting that shown for us. Really good.
Yep,
Appreciate
no
it.
problem.
Yeah, and totally on show topic too. We really appreciate that. Well, like I said, the subject for today is Enstatites, Rumuruti, some ungrouped ones, and then the really far out there stuff that Mike's going to get into on this week's edition of Meteorite 101. Mike, I'm going to hand it over to you right after this one slide. This kind of shows where we are in the classification table that we've been going back and forth with. So we are in the chondrites, which are 94% of the falls. 85% of the falls. But we're dealing with the very, very rare Enstatites, Gs, Ks, and Rumurutis, and F class. So with that, Mike, take us through, please.
Certainly. So I started off with the oxygen isotope plot here to kind of show you what we're talking about. And I highlighted the Rs, which you see sitting a little higher in the oxygen 17 content than the ordinaries HLs and LLs. And then you have slightly lower in 17 and higher in oxygen 18 for the EHs and ELs. And then the Kakangari type chondrites are very, very low in the 17 and 18, sitting there right around where the CRs are located at. So starting off with the Rumurutis. So Rumurutites are named after Rumuruti, which was a fall in 1934. It was a January 28th fall at night, and it fell in Kenya, and there were several stones recovered, and kind of keeping with the trend of the type falls, of course, there's very little of it left actually accounted for. One main stone, which you see in a picture off the MetBull, is in a museum in Germany. And that's just about all the world has left of Rumuruti.
Wow.
So an interesting fact about the Rumurutites are before they were Rumuruti-like, there's actually a Rumuruti that predates them, which is Carlisle Lake, which is an Australian find. It's not an overly large meteorite. It's small. It's in a series of Carlisle Lake finds. So all the other ones were ordinary H chondrites, and this one was an oddball. And Rumuruti, if you actually look in the MetBull, says Carlisle Lake-like before the class of Rumurutites were made. So, of course, it's kind of the same thing with the other carbonaceous group we talked. You don't want a grouping called this, the Cs, because that's confusing with carbonaceous. So since Rumuruti was the only fall of all the Rs, which there are 278 of them now, they are named after Rumuruti.
I like that name too.
Yep. A little bit about the material. They are very high in olivine, 70% olivine content. And the other thing that's really interesting about them is they're very highly oxidized compositions. So a lot of oxide minerals inside there. But what's interesting is you can't get to those type of oxides and the mineralogies that you have just by basically oxidizing a normal ordinary chondrite. So that's kind of proof in of its own that they are a separate parent body material. They also are really rich in things like sulfur and selenium and zinc, which is kind of odd for the ordinary chondrites. They're all lower in those three elements. And again, they do have their own separate oxygen isotopic plot area on the chart, further proving that they're separate. One of the interesting things is they are a very brecciated material. Looking at the total for the entire group, more than half of them are breccias, and they do range from unequilibrated, so down into the 3.4 range, all the way up to the 6s. And about half of those that have been studied for noble gas composition have basically embedded solar wind particles in them, meaning that they're regolith breccias.
Cool.
Wow.
Oh,
That
wow.
is fascinating. Right now we actually have a video submission from Damian showing us some really beautiful photography of some of the Rumurutis in his collection. So we actually get to see some Rumurutis up close while we're learning about them. Wild looking stuff.
Beautiful.
Very nice.
Nice bright chondrules.
I like that black and white half chondrule.
Bleached chondrules in that one too.
Nice dark matrix in that one.
Yeah, almost lunar looking.
Yeah.
Yeah.
A lot of matrix.
Very crystally.
Hmm.
That one's almost purple, that chondrule.
Yeah.
Oh my goodness.
Oh, wow.
Hmm.
That's crazy.
His photography is just mind blowing.
Oh yeah.
Yeah.
He's on
So
fire.
that is amazing stuff.
Nice.
Very nice.
It was interesting how some of the chondrules almost looked like they were kind of blurring with the matrix a little bit in some of those.
This one almost looks carbonaceous at your first glance.
Yeah, it does.
Yeah,
And this
lots
one
of
almost,
matrix.
and that one almost looks lunar at your first glance.
It
So,
does look like a
well,
Yeah.
I'm glad that Mike's teaching us the science of how they actually tell them apart. So, Mike,
Nice.
I'm going to kick it back to you for the Enstatites.
Certainly. So the Enstatites are kind of an interesting group because they're not named after any specific meteorite. They're just named after the fact that basically their major constituent in there is enstatite. So that gives them the E name. And one of the things that's neat about them is they're almost the polar opposite of the Rumurutites. So the Rumurutites were very oxidized. These are very reduced, which means there was very little oxygen around to be incorporated into the mineralogical structures. And it also means that the iron you do have in there is free iron. You know, it's not oxides. So again, they are really heavy on enstatite, which is a type of pyroxene to the tune of 70-80% by weight. They do have that free metal, which makes up pretty much the rest of them, 20 to 30% by weight. And they do have a smattering of sulfides and other sulfur-based minerals in there. So you see like oldhimite on there and the monosulfides. So those are all kind of lesser abundant, 1 to 2% or less type minerals on there. You obviously see Ninningerite there, named after Ninninger.
I was about to ask.
You know
Nice.
you know you're a big deal when you have a meteorite-based mineral named after you.
Yep.
And so the enstatite chondrites are broken down into two main groups. There's the ELs, which represent low metal, and then there's the EHs, which represent the higher end of the metal on there. And there are actually some papers that break down each of those groups into two subgroups like ELA and ELB, but that hasn't been 100% formally adopted yet. They do display the full spectrum of unequilibrated to totally equilibrated. So that means they go from the 3s all the way up to the 7s as the number you see behind the EL or the EH. And as you showed on that chart, Topher, they really are a very small percentage of the total known meteorites, like a percent and a half each or something like that. There's only 204 of the EHs and there's only 207 of the ELs. And the secondary numbers I have down there are there's 9 falls that are EHs and there's 8 falls that are ELs.
And now we get a chance to look at some of Damian's Enstatites. Very weathered.
Mhm.
Yeah.
Oh, excessively.
Nice layering.
Ifby.
Yeah, that's a bizarre one there.
Yeah, I would love to have me some of
It is a
that.
strange one.
Oh, I would love to have that too.
Yeah.
And notice the triple junctions in this.
Yep.
It reminds me of a cross between a bencomonite and an enstatite.
Very
Let's-
nice. Thanks,
so-
Donnie.
Yeah, thank you, Damian. Great work on that.
Excellent work.
Oh, it's fabulous.
And let me see if I can back. There we go. Exactly what Pat was saying about triple junctions. You can see them really at play here. One,
Wow. Yeah.
2, 3. 1, 2, 3. Everywhere you look.
Yep.
Yeah. So beautiful photography and great samples as always, buddy. Thank you.
Yeah.
Certainly. The Kakangariites, or named after Kakangari. This was a relatively small fall, 350 grams in India a long time ago, 1890. So these things are interesting. They have an enstatite-rich matrix, but a pyroxene and olivine-rich chondrule content. And they are really, really high in matrix content. So 70% of the meteorite is matrix and only 30% is chondrules, with a smattering of troilite in there and a little bit of camosite and taenite. What's interesting about this group is this is the smallest thing that gets called a group, even though it has less than the number of members needed to be a formal group by the new rules, which is 5. So there are only a total of 4 of these between the K3s and the K4s. That's as far as the petrology range goes. And there's only the one fall, which is Kakangari.
Dang.
And these are interesting. So they are much more reduced than ordinary chondrites. So again, that means low in oxygen content in the mineral structures. They kind of sit in the zone between the ordinary chondrites and the enstatites as far as how reduced they are. So the photos here is a photo of the actual main mass in still over in India, courtesy of Dave Weir's site. And the bottom shot is actually a very, very blown up piece of Kakangari that you get to see later.
Oh, wow. Yeah, I have a question about it because I don't know what I'm looking at. So that's awesome. Little teaser.
Ungrouped chondrites. So we talked about things like the G chondrites and the F chondrites. And those are proposed new classes. Again, they don't have the population yet to kind of fully support, being an officiated group. So right now, they're kind of where things might go if more show up. So starting off with the G chondrites, I know there was a question out there. What's the metal content? It floats around 23%. So Sierra Gorda 009 was mentioned, and that one has 23% metal content. So it's not necessarily incredibly high. What's very interesting about the G chondrites is that they're kind of similar to H's, except they really don't have much matrix in them at all. It's almost all stuck together chondrules. And they are also a very reduced type of meteorite. So again, they have a less oxygen fugacity in them than you would see in the ordinary chondrites. And they have an oxygen isotopic that also sits kind of in between the ordinaries and the enstatite chondrites. Again, there are only the 2 of them out there right now, and they are would be named after, if it ever goes official, after Grasanov Mountain, which is in Antarctic. So won't be getting that one.
Yeah. Well, I was very fortunate when I was in Tucson that I walked into one of my friend's store and he handed me a meteorite and tried to stump the dealer. Like, he knows I like educating people. I like being educated. He put it in my hands like, what is it? Well, here's what it was. This is an extremely rare chondrite. It looks as though the metal in it is a mesosiderite, and that was my first guess, but it is a chondrite. It is a G-type chondrite. Probably one of the most unique chondrites that I've seen, besides 13202.
Pretty much just chondrules and metal.
We're at the comet shop right now.
Yeah, chondrules and metal. That's it to it.
Yeah. So that is Sierra Gorda 009. Yeah. I was, and of course I had no idea what it was.
So this one's titled Xenolithic Chondritic Materials. This is actually your F chondrites. Again, same thing like with the G's. There aren't enough of them out there in order to make it a grouping yet. What was really neat about this is they were originally just found as classes of chondritic material in 2 different aubrites. So we had no chondrite meteorites that looked like this. They just had chunks within aubrites that had almost pure fosterite composition to them, which didn't match any of the chondrites that we have in regular meteorites. So for a long time, it was just those two specimens, and one of those two was Cumberland Falls. The other one was in Antarctic. And then later on down the line, they found two meteorites, NWA 7135 and El Medano 301, which fit the bill for those clasts. So they're thinking that the parent body of these F chondrites ran into the Albright parent body as one of the impactors in the history of the Albright parent body, and that's how that material all got mixed in there. But just kind of waiting around for 3 more to show up.
That is so cool. I love when I'm putting the slides together that you create. I saw that and I was like, whoa, that's cool. That is awesome.
Really nice.
Mike, as always, thank you so much for your efforts and your energies and your knowledge and time. Appreciate it, man.
No problem.
You deserve some applause.
Thanks, Mike.
Yeah. We're going to jump into a video from Roberto Vargas about his ungrouped chondrites, and then we'll do more show and tell.
All right.
Hey, Knowledgeable Ed crew. Sorry I couldn't make it to the Hangout tonight. I'm flying to the Enstatite Meteorite show in France. But Sue asked me if I'd be willing to share some of my ungrouped chondrites. So I figured I'd put together a quick video for you guys. Hope you enjoy. So first up, that's NWA 5492. It's an ungrouped chondrite. It was found in 2008 in Northwest Africa. It has a total known weight of 593 grams. According to MetBull, the oxygen isotope data suggests a relationship to CB chondrites for the large barred clasts in this meteorite, whereas the small reduced chondrules and fragments have oxygen isotopes that fall more in line with E chondrites. Next up, I know Topher has a piece of this, is NWA 13202. This one's also an ungrouped chondrite found in Northwest Africa. It was found in 2020. Total known weight on this one is 396 grams. This one's really cool because it's, like, according to MetBull, it's 75% metal and 25% silicate-rich material. MetBull also says that texturally, this meteorite resembles, again, bencombinite-like carbonaceous chondrite, but oxygen isotope is completely different. So it's a chondrite, but it's still ungrouped.
Nice. Thank you so much, Roberto, for submitting that. I know that you are on a plane on your way to Europe right now, so thank you very much. Mike Kelly, you have some show and tell for us?
So in that presentation, you saw Kakangari, and that was about 500 times magnification, because that is all I own of Kakangari right there.
Wow. You're lucky to have any of that.
Yes. So keying in on the lucky to have any of it, I know of 3 privately held pieces of this.
Wow.
Don't ever open that.
It was opened up to take that 500 times magnification shot.
Wow.
But that's one of the crown jewels in my collection right there. As small as it is.
To say how you got it?
I was visiting a friend who owns one of the other 2 pieces of publicly held pieces of Kakangari.
Wow.
I know who that is. Nice.
Is that your smallest micro then, Matt?
Yeah, that's probably my smallest micro. But again, that was one of those ones where I never thought I would get the K type fall checked off of my type fall collection list. So
yeah, it's pretty rare.
Yeah, that's about as rare as it gets.
Is that the one that started at 350 grams?
Yes.
Wow.
Yeah.
Well done, Mike.
And so even at that size, when you magnified it to 500x, it wasn't a uniform structure. There was
you could see the little bits of metal in there, and you could see the enstatite rich matrix going on with it. So
that's pretty cool.
Yeah. Even at that tiny amount, it definitely has a distinct look to it.
You get the grand prize for that.
Oh,
for most meteorites, when you're at that size, you get a fraction of a convol.
Yeah. This is a Rumuruti. This is an R3. It's NWA 14126. And I picked this one to show because it has a good example of that brecciation going on.
Very nice.
So even though this is all R3 material, you could see it's obviously been broken up into class and re-solidified.
Nice.
And this slice actually, if it'll focus, has a nice little bit of crust along that edge by my thumb.
Great color too.
Sweet.
And again, you can imagine this being on the surface of an asteroid, getting all broken up and remixed up, and that's why it has all that solar wind incorporated into the material with trapped little bits of noble gases in there.
Sweet.
Which number was that again?
This is 14126.
Thank you.
That is beautiful, man.
We did mention that some of them are subtyped. So you can see there's a lot of beautiful chondrules in there. This is NWA 4360. And this is not a brecciated Rumuruti. This is just straight up R3.6.
Nice.
Very nice.
So yeah, there's 4 total types of Rs, and that's one of the 4.
Is that the only 3.4?
This is 3.6.
I'm sorry. Is it the only?
I believe it's the only 3.6. I think there are a couple 3.6s.
Okay. Wow.
I can go pull the numbers and put it in the chat.
That's fantastic.
This is a 3.8. So this is NWA 978, and this is an R3.8. So the chondrules aren't quite as spectacular in there. They're a little more equilibrated. And the last one I had is Happy Canyon. So this one is it started out as an E7, which meant it wasn't broken down into one of the 2 groups. But further science was done on it, and it is now a EL 6/7, which makes it the only EL 6/7.
And a lot of metal in that one, Michael.
Yeah, that's kind of the surprising thing is having gone and visited other people with some ELs, some of them strikingly have what seems like a lot of metal for being called an EL.
Mm-hmm.
So the magnets stick to that or not at all?
Oh, yeah.
Michael,
Awesome.
could we get one more look at that R3 with all the breccia? That your big slice? That is so pretty. That's going to be a wonder under the microscope.
Yeah, there's a lot going on in there. So that's this is my largest slice of R. I'd like to touch on what Topher mentioned at the beginning of the show. Like I buy relatively inexpensive pieces. I don't spend a lot per piece. So even if you're getting rare stuff, you can get rare stuff, at a decent price if you look around. In addition to the prolific amounts of NWA unclassified that's got beauty going on with it.
That's really a sweet piece.
Wonderful.
Thank you very much, Mike, and I appreciate you backing me up on that.
Oh yeah.
I'm gonna bring it full circle and show you a half stone Rumuruti and then a Rumuruti that is a great. I don't like selling on these things, but it's a great purchase for someone who wants to cut a cheaper but cool stone. So let me show you what this Rumuruti is. If you are a longtime watcher, you have already seen this one. This is NWA 13758.
Crust on that.
Yeah.
Love that.
Yeah. Let me put it back out here.
Very, very lizard-like.
Wow. Really stippled and thick crust.
That's a crazy crust.
Nice texture.
That's what we're talking about today, though.
Oh, yeah.
That
That shows everything of what we were talking about.
Microscopic dream.
Very appreciated.
So there is a ton of stuff going on in there. And here is a partial stone, but it's an uncut stone. So this is what it looks like in its uncut form. You can still see the chondrules poking on out.
Yeah.
Pretty sweet.
Mm-hmm.
I don't know what that is right there. Feels like about 150 grams, maybe.
Very nice.
But yeah, it doesn't really doesn't really give away that many secrets from a crack side. But the exterior, you can definitely, if I had cross polarized light, you'd be able to see a lot more.
Oh yeah.
Yeah. But this is a nice example. Let me put it right there.
No need to wonder what's going on in there from that one side.
No.
Oh wow, it's a little heavier than I thought. It's 245 grams.
Wow, nice.
Wow.
Yeah, that's pretty big.
It's just waiting for someone to cut it. Awesome.
Who would that be?
I have no idea. Someone with a saw and a little bit of free time. It's that wonderful time of the month where we check in with my wife, Sue, for the monthly MetBull update. So, Sue, take it away.
Hey guys, I hope you're all doing well. So here I am again reporting on the MetBull update, and these are for the classifications that were approved and published in May. So moving to classifications, including the Antarctica classifications, we had 232 classifications approved and published. And I'm going to go into it a little bit more later, but there were 2 that were discredited, and then one that was consolidation. And those 3, the second and third numbers that you see there, they're related to each other. And then we had, out of all of those, we only had 1 witness fall. And then the rest of the numbers that I'll be discussing for the rest of my segment will not include the Antarctica ones. So can anybody guess what the smallest classification last month weighed?
I'm going to say.
Any takers?
Less than 20 grams.
How much?
In grams, yeah, in grams.
Less than 20 grams.
Correct.
Say less than 10 grams.
Correct.
2 grams.
It was 3.1 grams.
Wow.
Oh.
Yeah, it's crazy how small some of these are. Can anybody guess how many classifications we had that were under 1 kilogram total known weight?
Out of the 220?
Mm-hmm.
75.
A lot of the
It's a little bit under the 200, minus the Antarctica ones. So yeah.
Yeah, because a lot of the Antarctic ones, they each get classified, and so if there's 10 pieces that are all the same meteorite and weigh a gram, they all get classified.
Right.
Absolutely. There weren't too many of those this last month. It was I want to say around 190. But yeah.
Cliff says 75. Allison says 20. I'm gonna say 102.
Cliff was the closest. At 79 of those were under a kilogram. And
wow.
I don't remember exactly, but I want to say it was almost close to around 50 that were under 100.
Wow.
Can anybody? Yeah, I know.
I think that was Chris actually that guessed that.
Oh, okay. I assumed it was you, Cliff. Sorry about that. And I believe the largest one was, I want to say about 25 kilograms.
Wow.
Okay, so we had a lot of different classifications and a lot of rare ones. Under our primitive chondrites, we had the Acapulcolite, we had 27 carbonaceous, we had 21 of the HED meteorites, we had 10 lunar, we had 4 Martians. Under our stony irons, we had 3 mesositerites and 4 pallasites. And under our ordinary chondrites, we have 48 H's and 74 L's and 23 LLs. We had 4 irons, and we had, and this is on topic, we had 7 Rumurutis.
Nice.
Oh, that's a lot.
That's a lot.
Yeah, I don't normally see 7 Rumurutis in 1 month. But,
That's a lot.
oh, and 2 bononites and a Urolite as well. Yes, the locations. Okay, so wanted to give you a good representation of where the meteorites have been found. And this is not including, of course, the NWAs and the ones that are classified as Western Sahara. But as you can see, we didn't have any in the United States, and I believe we only had 1 on the western side of the world. Most of them are still over in Egypt and all the other African countries, and Morocco, Mauritania. We had some in Asia and some in the Middle East as well. We did have one. We had a few over in Europe too. We had a Poland and a Norway. So yeah, that kind of gives you an idea of where they're being found. Okay. So yeah, a few interesting things to note. Yeah, our oldest meteorite that was found, and this has kind of happened 2 different times, and that was with the and I'm not exactly sure how to say it, but the Kochesievo and the Augusta Pestana. But the Russian one was one of the older ones, and then there was one from Poland that was really old, and one was found back as far as 1943, and as usual, nobody knew what it was, and it was just put away. And someone later sent a sample in like 2021 and found out it was a meteorite. And that also happened with the one in Brazil. And somebody was cleaning up an estate and found a meteorite that had been stored for decades. And then Niger, they had there were classifications that were entered back in the 1960s, and they ended up classifying them, I believe, as L6, 2 of them, and then another one as an LL6. And there were some controversies surrounding this, and finally, I guess just last month, they decided to discredit 2 of them and decided that they were not part of 3 different finds. They were the same meteorite. And so it is, they settled on L6. And I just wanted to recap. We had, Chris had his 2 first classifications last month. And one, yeah. I know everybody's always really like anxious and waiting for their classifications to show up. And these days it seems like because there are so many being classified, it's taking longer and longer. So it's exciting when they finally do hit. And another one I didn't have on that slide, I just put in more. But one of our friends of the Knowledge Bolide crew, Matt Stream, he joined us for the feature on the Cranfield fall. He had 2 classifications last month, and it was 1 lunar and 1 Martian, actually. So congratulations to Matt.
Yes, congrats, Matt. Way to go.
And we just, every time I check the MetBull, I'm just kind of crossing my fingers and waiting for our buddy Pat's classifications to show up. So any day now, any day.
Yep.
Awesome. Thank you very much, Sue. I really appreciate that information and your monthly updates. I know you put a lot of work in them, so thank you very much from the crew. All right, guys, thanks a lot for joining us this week. I really appreciate it. We'll see you in 2 weeks. Bye-bye.
Bye.
Bye, everybody.